Hello and welcome. So you have been doing experiments for electronics using the PHET circuit simulator or FET circuit simulator, depending on how you want to pronounce. And now you have reached time to incorporate some more complex components. And so we're going to do that using a different program. So far, you've been doing your circuit simulators using something like this. This one is great. It's really easy to use. The multimeter and the voltmeter, or sorry, the ammeter and the voltmeter are really, really user-friendly. And you can just pop it on there, and it's real easy to see what the current voltage, what the voltage and current is. So I can pop it on and say like, oh, perfect, 9 volts on the battery and a current of 1.1 amps. The one thing that it struggles with is that it doesn't have very complex electronics components. So I have things like battery and light bulb and resistor, but I don't have a potentiometer or a capacitor. So when we want to do some more complex stuff, I've got like a dollar bill and a paperclip and an eraser, but those are not traditional complex electronic components. So to do a little bit more complex stuff, you're going to open up the TinkerCAD Circuit Simulator. So you're going to go to tinkercad.com/circuits. You can scroll down and click Launch TinkerCAD Circuits. It might take you to a login page, and then in that case, you just log in with your students.nusd account. So click Login using Google, and then go with your students.nusd.org account. Or your regular student's account, or if you don't have one of those, you can use your personal Gmail account, but you want to log in using Google here. Then you can take this and set up a system. So I'm going to use first a breadboard. So if I scroll down a little bit in my basic components on the side, I can click on breadboard small and then drag it in. If it's able, there it is. So you can drag in your breadboard, oops, and I've started making wires on it, which I didn't want. So instead, I'm going to click on my breadboard and then try to drag it to where I want it. And I like my breadboard to be sitting vertically, so I'm going to go over here and rotate it a couple times so that it sits vertically, because I think it's easier to orient that way. I'm also going to grab a 9-volt battery because we're going to run things off of a 9-volt battery here. Doesn't matter what I name that 9-volt battery, but I am going to connect my negative side of the battery to negative. And I'm going to change that to a black wire. And the wires are really easy. You just click where you want them to go. And then I'm going to connect my positive side to the positive line on the breadboard. And I'm going to make that one red because positive is traditionally red. Also, while I'm at it, I'm just going to connect the positive over to the other side positive. This way, I'll be connected into either end. It's just like a nice starting point. And I'm going to connect my negative side over to my other negative line on the other end. And that way I can go into either direction. Oops, and I don't want that red. I want that black because it's negative. So this is just a good way to start all of your circuits because it makes things really easy going forwards. All right, so now I know my red line on this side is positive, my red line on this side is positive, my black line over here is negative, and my black line over here is negative. So now I'm going to look into my breadboard experiments, and you just finished up question 28, where you are finding that current is inversely proportional to resistance in parallel circuits. And now we're going to introduce some new components, such as a potentiometer. So potentiometers are resistors that can dial up or down. A place that you might have one of these in your house is like a dimmer switch on a light bulb or on a light. So you can change the resistance by like sliding it or twisting it. So we're going to go into the potentiometer, and a potentiometer, you can read through this and look at the diagram, but a potentiometer is basically like a little slider along a variable resistor. So the current would come in through A, it would go around the variable potentiometer, and then it would come out through this moving part, which we call the wiper. So you're going to connect one end of the potentiometer, and you're going to connect the middle wire, which is the wiper. I could also go in through the other side. I could go in through B, it could go around, and then it could go back out the wiper. It doesn't matter which end I connect to, as long as I connect to the wiper in the middle and one of the side pins. All right, so I'm going to set up this circuit. I've got a circuit diagram for it, and I want to set it up with a resistor and a potentiometer. The resistor connects over here to the positive side of the battery. The potentiometer connects to the negative side of the battery, and the resistor connects to the potentiometer. It also asks me in the instructions to make sure that my resistor is at least 100 ohms, and my potentiometer is about 10 times larger than that. So I'm going to try to follow those instructions in my TinkerCAD circuit simulator. So the first thing I need to do is grab a resistor, and the resistor connects, so I'm going to click it and drag it over. The resistor is going to connect to the positive side of my battery. There we go. And then right now I'm connecting it to different lines, but none of them is the positive end of the battery. So I could either connect a line over to my positive side of the battery, and that's probably the easiest option. But first I've got this resistor, and it's currently set at 1 kilo ohm. So I'm going to change it to 100 ohms, regular ohms, not kilo ohms. And now I have a 100 ohm resistor. Now I need to connect my resistor there to the positive side of the battery, and now it's connected. And since that's a positive connection, I'm going to make that red so I remind myself that's a positive connection. The other option that I could do is I could take my resistor, I could click on it, and then I could rotate it like that, and then I could shift it over so that it's actually physically in the positive and then into this line. It doesn't really matter which way you do it. Either way is fine. I'm going to rotate it back so that it goes back to the way I had it right there. So I have it positive through the resistor, and now I'm into line 10. All right. Next, I'm going to go from that resistor into a potentiometer. So I'm going to grab a potentiometer, pull that guy over, and I'm going to put my potentiometer in the next line. I'll put it down here so that I have a lot of space for it. And right now, the 3 pins are all in the same row. That means no current will go through the potentiometer, so I have to rotate my potentiometer so that I put them in 3 different rows. So I've got them now in 18, 19, and 20. 19 is the wiper, so I have to have a line going into the wiper, and then I can come out of 18 or 20. So I'm going to make my connection from line 10, that was where my resistor came out of, into the one that I have to go into is line 19. There you go. And I can leave that one green. And then it's going to come out of the potentiometer, which is in line 20 there, and it's going to go to the negative side. I could go to the negative side over here because that is connected to the negative side of the battery, or I could switch it. Oops, I've managed to double click it. Or I could switch it and go to the other side of my breadboard. Personally, I like going to the opposite side of the breadboard. It just makes kind of logical sense for me to read it across the screen. So I'm going to click over here to my black line, which is connected to negative. So now, if I trace my circuit, I have positive side of the battery to the positive line on the breadboard. That connects to one side of the resistor. The resistor is a 100 ohm resistor. Yep. And it connects through this wire to the wiper on the potentiometer. It'll come through the potentiometer and then out through this line. And then it'll go over to the negative side of the battery. The negative side of the battery is connected over to this negative, which is connected to the negative side of the battery. So I'm good to go. The last thing that I wanted to modify is just to change the value on my potentiometer. I had a 100 ohm resistor, so I need a 1000 ohm potentiometer. A 1000 ohm is the same as a 1 kilo ohm potentiometer. So now I've got 1 kilo ohm, I changed it there, and then I can click, and now I've got all the right components. So I could start my simulation, and it's running. And nothing is catching on fire, so that's great. But I can't see anything going on. The one thing that I can do now that it's running is I can move this potentiometer, and increase and decrease the resistance, but I don't actually know how much I'm increasing or decreasing it because I can't measure anything. So what I'm going to do is I'm going to stop my simulation so I can make some changes, and I'm going to look up a voltmeter. So I'm going to look up voltmeter. Nope. So instead, I'm going to look up multimeter. There you go. Multimeter, and I can grab a multimeter and pull that guy over. So these multimeters are not quite as easy. It's currently set to voltage, and I'm going to need to connect my positive line here to something positive. So there you go. And I'm going to make that one red so that I remember that it's the positive end. Then I'm going to connect to my negative side and go to something negative there. And I'm going to make that one black so that I remember that it's negative. Okay, so I'm connected to the positive end and the negative end with my multimeter. My multimeter is set to voltage, so it'll be reading the voltage. And in my experiment, it says, use your voltmeter to measure the voltage across the battery. Okay, perfect. So for the voltage across the battery, I'm connected to the positive side of the battery. I'm connected to the negative side of the battery. So now it will read my voltage of the battery if I start the simulation. So I start the simulation and it goes up to 8.98 volts. The battery says it's a 9-volt battery, so that's pretty darn close. Those missing 2/100ths of a volt are probably being lost to the resistance in the wire itself. I could double check that by moving it. Oh, and I forgot that when I'm running the simulation, I can't move anything. So I have to stop the simulation, move this line over. Nope, in order to move it, I have to click on the red wire, then click the end that I want to move and place it on there. Same deal for the black wire. Click the black wire, the negative value. There you are. And then click the end that I want to move. I'm going to go right to black. And then let's start the simulation again. And it still reads 8.98 volts. Apparently this says it's a 9-volt battery, but it's not like a perfect 9-volt battery. It's actually an 8.98 volt battery, which is close enough. All right, I'm going to stop my simulation, and I'm going to click on my black wire, move my black wire over so that I can find the voltage over the resistor, and then I'll click that one and shift that one so that I can find the other side of the resistor. And I actually did not place this black wire correctly. It's not placed on the resistor. I was off by 1 pin. So I'm going to click it again and move it so that it's in the same row as the resistor. Now I have a connection to one row that the resistor is in and a connection to the other row that the resistor is in. I'll click Start the Simulation again. And right now my resistor is resisting at 1.6 volts. So if my resistor is at 1.6 and there's 9 volts total in the battery, I should have another 7.4 volts over here on the potentiometer. I'll stop the simulation and double check that, see if that's actually true. I'll place one in there on the line for the wiper. I'll place the other in here on the line coming out to the negative side and see what it reads. And it reads negative 7.37. That's very close to 7.4. You'll notice that it reads negative instead of positive. That's because I made a slight mistake, and I placed my black line, negative, in the positive end, and my red line in the negative end. So now it's just going to read the backwards one. If you just take the absolute value of this number, you'll always be fine. You can just record this as 7.4. So 7.4 on the potentiometer plus 1.6 on the resistor, I'm in good shape. Now, the one thing that I can do while I'm here is I can change my value on my potentiometer. So if I change my value on my potentiometer, if I push it all the way over here, I can get as high as 8.17 volts. That means the potentiometer is holding as much voltage as it can hold. 8.2-ish would leave about 0.8 over here. Since this has a maximum of 1,000 and this has a maximum of 100, the potentiometer could be 10 times greater than the resistor in voltage. 8 is about 10 times more than 0.8, or in this case 8.2, and 0.82, because 8.17 leaves 0.83 left over. So I've basically got 8.2 on the potentiometer, 0.82 on the resistor, which means the potentiometer must be turned all the way up to 1,000 ohms. Now I could move it back and I could go all the way the other way. If I take it all the way down, the potentiometer can get as low as 44 millivolts. That's 0.044. Technically, I should be able to take this all the way down to 0, but it looks like it's minimizing at 0.04. So there's still a little tiny bit of resistance there. And you can see as I scroll up here, the numbers get bigger. I'm up to 6 volts. I'm up to 6 volts there. And then if I scroll down, it's not super precise, but I can get down to 5 volts, 4 volts, 3 volts, 2 volts, 1 volt, and then down to like 0 volts effectively. Remember, milli means 1/1000th, so this is 44 1,000ths of a volt. 0.04 volts. I'm going to stop my simulation for a second, and I'm just going to double check if I move this back over and check my resistor there, and then I'm going to click on that black wire again and move him over so I can check my resistor again. Since this one is now set to have almost no resistance, it's only got 4 100ths of a volt, 0.04 volts, the resistor should now have almost all of the voltage. So I would expect this to be reading 8.9, 8.95 volts. Let's start the simulation and see what it reads. 8.82. So it's not quite as high as I imagined it would be. This potentiometer is clearly holding just a little bit more than I would expect. But I've got it set up right. I'm reading on either side of the resistor. The potentiometer is as low as I can get it. I could, however, shift it up. And as I shift it up, I'll notice that I get less and less voltage on my resistor as more and more voltage is held on my potentiometer. Remember when we first tried the potentiometer, we had 8.17 volts over here. Now I have it set to that same value, and I've got 817 millivolts. That's the same as 0.817. So 0.817 is exactly 1/10 of 8.17. So 0.817 is a totally valid reading there. It looks like, yes, this would be 100 ohms. This would be 1,000 ohms right now. Grand total of 1,100 ohms of resistance for this circuit. So I can scroll it up, scroll it down, and I'm in good shape. Okay, I go back, use my voltmeter to measure the voltage across the battery and the voltage across the resistor and the potentiometer, twist the potentiometer until its voltage is 0. I got as close as I could. And the resistor and battery have the same voltage. I didn't get exactly the same, but I was close. What is the resistance on the potentiometer right now? I know, okay, so resistance on potentiometer is 0 because it has 0 voltage. And then I'd say, like, actually, resistance is very low, but not quite 0. Ohms, because it's reading 0.04 volts. So that's where we get like the theoretical is what we should be able to get. And then the practical is the components are not like perfect. In fact, they have like an error ratio, and most of them, if you're within 5% of what they say they're supposed to be, that's good enough. So some of them it's like 10%, or some are, if you're getting really precise, it could be like within 1%. But by and large, if they're within 5% of what they're claimed to be, we say that is good enough. And in this case, it's almost zero, but not quite zero, but it's close. Out of 1,000 ohms of resistance, this one's getting down to, I don't know, 5 ohms or so. So it's pretty good. All right, now keep the voltmeter on the resistor and twist the potentiometer to increase the resistance. What happens to the voltage on the resistor? What happens to the voltage on the potentiometer, and why? Keep the voltmeter on the resistor. Okay, so I'm going from 0 on the potentiometer. So the voltage on the resistor went, see, if I had it at 0 on the potentiometer, I'm having to remember what I did. If I had it at 0 on the potentiometer, and then I twisted it, I would increase the potentiometer, and that would decrease the voltage on the resistor. Okay. So voltage on resistor decreased to 0.817 volts. Voltage on potentiometer increased to 8.17 volts. Cool. And then why? Because we turned up the resistance on the potentiometer to 1,000 ohms from almost 0. So it now holds 10/11ths of the total resistance and voltage. And it's 10/11ths because the potentiometer was 1,000 ohms, the resistor was 100 ohms, 1,000 plus 100 is 1,100, so that's 1,000 out of 1,100, which is 10/11ths. All right, so you are now, I believe, in position where you can kind of keep going, do the math on there, use the voltage of the battery and the ratio between the maximum resistance of the potentiometer and the resistance of the resistor to determine how much voltage should end up on the resistor and how much should end up on the potentiometer. Do the math. Okay, so this is where I'm doing a ratio. It's like 100 out of 1,100 for resistor is equal to 1/11th times the total, which was 9 volts, equals 8.17 volt. Nope, 0.817 volts, or it's probably not exactly 0.817, but it's close-ish. And then for the potentiometer, 1,000 out of 1,100 for potentiometer equals 10/11th times 9 volts equals 8.17 volts. Now, 8.1 or 8.817 and 8.17, those were actually our experimental results. I noticed that they don't add up perfectly to a full 9 volts, so I might be missing a little something in the practical ones, but it's close. So I should actually use a calculator and run that math. In fact, I will practice what I preach and do 1/11th times 9, and it's 0.818 instead of 0.817, which is pretty darn close. 0.818, and that means it's 8.18. So then experimentally, we found 8.17 volts and 0.817 volts. Pretty dang close. Yay! So I feel pretty good about that. I think that's a pretty successful experiment, all things considered. We got very, very close, and that can help me prove that the voltage was split in proportion to the resistance, because this is a series circuit, so the voltage and the resistance were split proportionally, and that the potentiometer is a resistor, and it can change resistance. Awesome. Okay, so now you're going to try doing similar things for a capacitor. I think you can actually do this one. You'll have to use the voltmeter again, or the ammeter. Yeah. And then do your lighting and LED one. So that is how you can use the TinkerCAD Circuit Simulator. Remember, you have to click Stop Simulation and Start Simulation, so you can move stuff once you have stopped the simulation. Didn't move where I wanted it to. So you can move stuff once you stop the simulation. If I do it now, I'm actually not connected to anything. So if I start the simulation, it reads 0 volts because I'm not connected to a part of the circuit. So I'd have to stop the simulation. That means I know that I've screwed something up. I could go back over here and say, okay, what if I connect to the negative side of the battery? Right now I'm connected to the negative side of the battery, and I'm effectively connected to the positive side of the battery. This line connects straight to the positive side of the battery here. So it should read pretty close to 9 volts. Start simulator, 8.98 volts, which is what we said our battery was. Wonderful. So I'll stop my simulation there. And that is how you can run some experiments using the TinkerCAD Circuit Simulator. Enjoy!